All right, let's look at review worksheet 3. This is fall exam review worksheet 3. And this first starts off with curve sketching. So we're given the function 4x to the fourth minus 4x squared. Find the below information. We have to find relative min, relative max, point of inflection. So max and min is going to come from the derivative. So we're going to find critical points from the derivative from f prime. So we find the derivative, set equal to 0, and then we solve for x. So we get x equals root 2, negative root 2, and 0. We put these critical points on the sine line, and then we test the slope at each interval. Here I can choose a large negative value, and into the derivative, remember we're plugging into the derivative because we're trying to find out the behavior of their slope. So plug in a large negative value into the derivative, or into the derivative here, you're going to get a negative value. And followed by a positive value. Here you can choose 1, you'll get a negative value. Plug in 5, for instance, and you're going to get a positive value. So based off of these sine lines, we know the behavior of our graph, falling, rising, falling, rising. So we know we're expecting a relative minimum at negative square root of 2 and that's square root of 2, and then a relative max at 0. Okay. But we also need to identify ordered pairs. So even though the x value is at negative root 2 and root 2, for relative min, we also need to identify the y value. So we plug these x values back into the original equation. Okay. Remember, anytime we're looking for a location on the graph, we have to plug into the original function. Okay. And in 0, we expect x equals 0 to be a relative max. So plug 0 back into the original equation. You're going to get 0 as well. So we know relative max is 0, 0. Okay. Moving on to second derivative, which we need to identify point of inflection. We set the second derivative, find the second derivative using power rule. Set second derivative equal to 0. Factor, solve, and we get plus or minus square root of 2 over 3. We put those two values on the sine line, and then we test each interval with the second derivative. Okay, so here I can choose negative 4, for instance. I'll get a positive value. Plug in 0, I'll get a negative. And then plug in a large positive value, I'll get a positive again. So there's a change in signs at these x values. At these critical points, so I know that I can, I'm able to, that these are point of inflections, change in signs. So plug these x values back into the original equation, and then I'll get my y values. Okay. Okay. Number 2, the total number of local max and mins whose derivative for all x is given by f prime is. So if we want to find total number of max and min, we can find our critical points. Now they already tell us f prime, so we can just set all this equal to 0, find our critical numbers, which is 0, negative 1, and 3, put them on the sine line, and then we just test values with the first derivative. Okay. Falling, a negative, negative, positive, positive, so there's only going to be one relative extrema, relative minimum at 0, and so choice B. For number 3, the polynomial function is decreasing on the interval. So if we want to find where the graph is decreasing, we have to go to the first derivative, find the critical points, solve for x, and then we test each interval. So we see that there's going to be decreasing in this interval from 1/3 to 3, so therefore D. Okay, moving on to interpreting derivative graphs. So it's important that students are able to look at f prime graph and be able to identify all these characteristics. Okay, and what I would like to stress is that when you're looking at a derivative graph, the first step is try and create your sine lines. Okay, if you create your sine lines, that will help make it a little bit easier to visualize what the graph looks like. If you can visualize what the graph looks like, then answering these questions becomes a lot easier. Right? So as we look at a derivative graph, we have to keep in mind that the y values on the derivative graph does not tell you the location, or does not tell you the location of the point on the graph. The y value now tells us the slope or the steepness of the original graph. So the critical points are going to be where slope is 0, because slope is 0 is where we're going to get potential max and mins. So we start off pulling the critical points from the x-intercepts. So 1.5, 2.5, and 3.5. We put them on the slope sine line. And then anything that is above the x-axis represents positive slope. Right? Anything below the x-axis represents negative slope. And then, of course, anything that is on the x-axis represents where the slope is 0. Okay. So we see that in this interval, the slope may be changing, but we're looking for the fact that this portion of the graph is above the x-axis. All this represents positive slope, so this all represents that the original graph is going to be increasing in this interval. And here we see the graph is below the x-axis, so negative means decreasing slope. Okay. And finally, in this interval, this last interval, is above the x-axis, therefore increasing slope. Okay. From the f prime graph, we can also create our second derivative sine line and be able to find information about concavity. So your relative max and relative mins are where your point of inflection will occur. So these are the critical points for our second derivative sine line. So 0.5, 2, and 3. Positive slope on an f prime graph indicates where the graph is concave up. Okay. If you remember, increasing acceleration is simply rate of change of velocity. And so if velocity is increasing, then we know that if that's talking about that that the acceleration is increasing. So here, positive slope indicates concave up. Decreasing slope indicates concave down, concave up, and then concave down again. Okay. So then we have all these change in signs. So that tells us that these x values provide point of inflection. Okay. So then we go and try to fill in these values. Okay, so relative min, we see that it will be at 2.5. Relative max, we see it will be at 1.5. Interval increasing, we just read the sine line to figure that out. And then interval concave up and concave down, we can look at the sine line to pick out that information. Okay, finally, let's look at number 5, identifying point of inflection, concave up and down from f double prime graph. Okay, if we're looking at the second derivative, then we have to kind of think about what the y value represents. The y value now represents concavity. So anything above the x-axis represents concave up. Anything that is on the x-axis represents where my second derivative is 0. Okay, concavity is 0. And then anything that's below the x-axis represents where the graph is concave down. So just like before, we're looking at x-intercepts to pick out critical points. So -4, 0, and 4, we put them on a sine line. Above the x-axis represents concave up, below represents concave down. And so based off of this information, we can fill in our spaces here.